We are ready to go.
Ready to go. Good evening. Welcome to the first presentation of RASC Victoria for 2026. It's January the 5th, and tonight I am your guide to the universe. So, we have an unexpected and delightful guest tonight. Oh, before I say that, is there anybody in the room or on the screen who is new to RASC Victoria? Maybe is here for the first time?
There are some people in the room, so maybe we'll start.
All right.
Should we start far over?
I'm Cameron. I went to one of the STAR things in the summer and wanted to come to this in the fall, but being out of the country until just before Christmas. So first time I'd come, but always had a fascination with astronomy and just would like to take part. So
Thank you. And I believe you said, or no? And yep.
Cal, just an observer. I really love astronomy stuff. Yeah. And I'm a fan of dance, I think.
Oh,
Okay, very good. Excellent. Is anybody else in the room never been here?
I've been here a few times.
Yeah, okay. And back to the online now. Thanks, Marjie.
thank you. Anyone online? Anyone on Zoom who has not been here before?
You will have to unmute your microphone if you wish to speak.
And I can't see you, so you'll have to speak up.
What you've got in here.
We're just passing around cookie to the
I'll survive.
Did everybody get me?
Yeah. So Chris and Randy, there is no one online who is new. I can't see, so I believe there isn't. All right. Okay, we are very fortunate tonight to have a guest speaker. She is on sabbatical this year, and Jim Hesser recommended Samantha Lawler. She is from the Department of Champion College and the Department of Physics at the University of Regina. Samantha has been a Plaskett Fellow at the DAO. She has worked with UBC with a colleague Erin Bowley, and she is in town to discuss, and this is her first of many of this presentation, to discuss her work on the artificial satellite problem in astronomy. She's had much international publicity, and she has been involved with RASC as a correspondent for JRASC, the journal, bi-monthly journal publication, since moving to Regina. Samantha does observational astronomy, planetary science, and dynamic modeling of exoplanets. She has a strong background in observational astronomy, and much of her work involves observing imaginary planets and dust using computer code. She studies the orbits of planets and how they evolve over time. She has studied the orbits of Kuiper Belt objects, and through them we can learn about how the giant planets migrated in the early days of the solar system. In exoplanet systems, we can use the structure of debris disks, that means dusty disks around the stars made by colliding asteroids, to find exoplanets that would otherwise be invisible. So tonight, Samantha is going to talk to us about astronomy versus the billionaire space race. Welcome, Samantha.
Cool. So hi, everybody. Thank you so much for fitting me in. I've never given a talk like sitting on a couch before with a Colorado, so this is awesome. Like, and I'm really sorry this is going to be a super depressing talk, but I've got a lot of good stories thrown in, and I have some action items at the end for things that individuals can do to help save the sky. So this very first image is so I've recently gotten into astrophotography as a total amateur. I don't know what I'm doing, but I live in this place of land of living skies, like for real. It's so cool that I have access. This is from my yard in Saskatchewan, right? And like, of course the camera magnifies the colors a bit, but this is not that much of an exaggeration. It was so bright. And if you look really carefully, you can see a line of streaks going across the top there. That's a Starlink train, right? They are everywhere. And this picture is from just when was that? November. So just a couple months ago.
I don't hear a thing.
Sorry? Oh,
He said he cannot hear me.
Can everybody else?
everybody else hearing me okay?
Yes.
Yeah. Okay.
Okay, so Peter, please try turning up the volume on your computer.
Oh. Okay. So I'd just like to remind everybody in all of these talks that astronomy is really the most ancient science, right? Astronomy is looking up at the sky, noticing patterns, and making predictions based on those patterns, right? And this is what we have been doing as humans for as long as we've been human. This is part of what makes us human, right? Watching these patterns in the sky is so important. I'm so grateful to be visiting you from Treaty 4 territory. If you, it's very slow to load on the other screen there. There we go. Okay, so if you don't know a lot about Indigenous astronomy, from a Canadian perspective, this book, Tipiskawi Kisik by Wilfred Buck, is really excellent. A lot of really powerful knowledge that's been passed down for thousands of years. And nativeskywatchers.com is another really good resource to learn about Indigenous astronomy from a lot of different cultures around the world. So this is a really good place to remind yourself of how we're so deeply tied to these patterns in the sky. Of course, many of us are losing access to the sky. Sorry, it changes on my screen much faster. Many of us
Sam,
are, yeah.
Just got a message from somebody out there that they're not seeing things.
Chris Gainor. It is on the screen, I believe. Is everybody else seeing it? Marjie?
Yes, I can see it fine.
Yep.
Yeah, so something's wrong with what you're looking at, Chris.
I'll just give people a bit of advice. You need to go look at the top of your Zoom screen and you'll see there's two tabs and one has Sam's screen on it. That's the one you need to click on.
Okay. And
Carry
yeah,
on.
keep asking if you because it's I get a lot of good visuals, so I hope you can see them. But yeah, most of us are losing access to the night sky, right? A lot of light pollution has increased dramatically, mostly because of LEDs, right? LEDs are great because they create more light with less energy, but because they're cheap, they're overused, right? So you can see examples of this right outside this building, right? I am so grateful that I live in a place where it's really easy to access incredibly dark skies. I can drive for an hour and get to Bortle 2 skies. I always like to pull up a light pollution map for wherever I'm giving a talk. This is one of the best places I've given a talk lately. Like most of the time it's like Toronto and like, oh, you could go into the middle of a lake maybe and see the stars. But you can go up island, you can go out to the West Coast. There's a lot of places you can still access the night sky quite well. But there's a new source of light pollution that you can't get away from anywhere on Earth, right? And this is mostly driven by SpaceX launching the Starlink mega constellation. There's currently almost 9,500 Starlink satellites in orbit. More than 10,000 have been launched. And they make up about 2/3 of all satellites. I just want to point out Scientific satellites are not the problem here, right? Most scientific satellites are small, right? They're like toaster sized, the suitcase sized, right? The few truck-sized satellites that are up there for science are there's just not very many of them. It's not a huge problem. The problem with mega constellations is that they are very large and there are a lot of them launched at once, right? And I'm going to complain a lot about Starlink during this talk because they're the first, but there's a whole lot of other companies that are lined up to do the exact same thing. And the problem is, of course, that they reflect sunlight long after the sun has gone down, right? I used to always ask, how many of you have seen a Starlink, right? But like everybody has seen Starlink now, so it's not everybody has seen it. And there's no rules, like there's no rules in orbit. There's recommendations that are not enforceable at all. and it's really getting brighter up there very, very quickly. So I have a really unique perspective because I see these satellites in my sky. I moved to a farm outside Regina in 2019, right when Starlink started launching, so I could see the satellites increase in my sky. It's the first time I could see the Milky Way from my back door. And I see them in my research data also, right? So this is a 3-hour exposure from Mauna Kea. There's a few, you can see little short diagonal ones. Those are actually asteroids. The long diagonal streaks, those are Starlink satellites that flew through the field of view in that 3-hour exposure looking for Kuiper Belt objects.
And that's all Starlink.
It's not all Starlink. It's probably mostly Starlink. Yeah.
You said 2/3.
Well, 2/3 of all satellites.
So
Yeah.
it's at least 2/3.
Yeah. And that image is actually from 2022. It's a lot worse now. So yeah. Satellites are dramatically affecting the sky now. I'm sure all of you are very aware of this, but I have this lovely movie. Let's see if it'll actually pull up. See how well this shares. So this is taken by an astrophotographer, Janine Holowachuk. She takes photos from kind of middle of Saskatchewan. So you can see the comet there, right? And you can see a whole lot of Starlink satellites that are flying through. You can see a Starlink train appear at the end there, right? When I first moved to Saskatchewan, I wanted to know how many satellites are going to be visible in my sky. This is a simulation I ran. So this is about when the images that Janine took started, right? So it's like that part of the sky that she's focusing on. It looks almost exactly the same. You can see those trails of satellites coming through in one part of the sky. I've never written a scientific paper that I've wanted to be wrong about before, but this was one of them. So when Starlink first started launching, they said they would get below magnitude 7, right? So this is showing, magnitude 2 is bright, 4 is very easy to see, 6 is getting to be about as faint as you can see with your eyes from a dark place. The recommended brightness is 7 or fainter, right? Which is larger numbers. None of the mega constellations have managed to get down to that. And then AST Space Mobile, which I'll complain about again later, they have started launching giant, like tennis court sized satellites. There's several of them up now. So here's a very silly simulation I did of if they have 200 of them or 400 of them is what they want to have. If you're in downtown Toronto on the summer solstice, you'll be able to see the moon, Venus, and a handful of AST Space Mobile satellites all night long in the sky. It's like so in Toronto, the human patterns have fully drowned out the natural patterns, and that's awful. Okay, so my area of astronomy research is Kuiper Belt science, so I need to stare at a spot on the sky and watch for things to move. We've actually had to change how we do our automatic detections because we get things like this where it's very clearly a Kuiper Belt object, right? It's trucking along and then a satellite flies through and just obliterates it. So you can see it in some of the frames there, right? So the typical Starlink satellite is millions of times brighter than the Kuiper Belt objects that we're looking for. Let's see, let's go forward here. So I wanted so I want to learn about what is further out there, what is on the outer edge of our solar system, right? So my area of research is kind of like testing the Planet Nine theory is something that I've been trying to do. So this Planet Nine theory, so these are all really distant Kuiper Belt objects. We're looking down on the solar system. This is their orbits, right? Neptune is like just a tiny circle in there, right? It's really big orbits that we're talking about. And so when the Planet Nine theory was first announced, all of these distant objects were on one side of the solar system, right? And so this is now, you can see there's still an asymmetry there, right? Is that important? So here's another way of looking at those very distant Kuiper Belt object detections, again, looking down on the solar system. The red dots are where they've been discovered. The white dots are where we could have found them based on where surveys have looked in the sky. And so you can see like we discover them where we look for them. And like you're right, that sounds very silly to say that, but it's really important to understand that bias, right? We have only looked in certain places on the sky, which means those biases are built into this distribution. How important is that, right? And the biases are really weird. They're based on so they're the Milky Way galaxy, right? We don't look for Kuiper Belt objects in front of the Milky Way galaxy because it's hard to find fuzzy moving dots in front of the Milky Way, right? This part of the sky is when that's up in the sky is winter on Mauna Kea, and it's just hard to get time, right? It's you're likely to get weathered out. So we haven't done a good job looking there. Over here is actually, I think it's the Coma cluster. There's some cosmology thing that makes it so that it's really hard to get solar system time at that time of year, right? And like these biases are built into every single Kuiper Belt survey. So one thing I'm working on now is a deeper survey. So this is that image that I showed you. This is from the Classy survey. We're trying to look at these deep red pie slices. We're trying to look in all different directions kind of equally and try to see, is there an asymmetry there? And we now have a different bias built in that will be changing and in all future surveys, right? So we're looking right in the plane of the solar system. In the summertime, the plane of the solar system, the ecliptic plane, is lower in the sky, which means it has more satellites, which means it's harder to find Kuiper Belt objects there, right? So there's this new bias that is now built into every single Kuiper Belt survey. So it's just a way that this is affecting real science now. Okay, so I spent so much time complaining about satellites and how the sky is changing, and I've been interviewed all over the place. Like, so I'm not trying to brag. I'm just trying to point out how incredibly freaky weird it was when this happened right near my house, right? So how did this happen that pieces of a SpaceX spacecraft fell on farmland right near my house, right? So I did not believe it when it happened. Like, yeah, right, a farmer found space junk, come on. And then I saw a picture, like, oh no, that's really space junk. Oh no, oh no, this is my problem. I'm the only professional research astronomer in Saskatchewan. Oh no. So to understand how this happened, first we have to talk about billionaires in space, because this is happening a lot. So Axiom is a commercial astronaut company, which is wild. I didn't know this existed. So these fine gentlemen, the governments of their countries paid lots and lots of money to Axiom to shuttle them up to the space station. In January of 2024, they did some experiments and hung out with the other astronauts, and then they came back to Earth safely on February 9th. I highly encourage you to go look at their website, because it's pretty wild, because they're trying to get very, very rich people to buy rides to the space station from them, because that's a thing now. I'm just going to go out on a limb and assume that nobody here is a billionaire, but it's still interesting to look at their website. And yeah. So they returned to Earth on February 9th, 2024. So they launched on a Falcon 9, a Crew Dragon. So this is where the astronauts sit in this little part up here. This is what's called the cargo trunk. So it's this big empty area that's not pressurized that you can put big things in, right? So these are new solar panels rolled up for the International Space Station. And when it's time for the astronauts to come home, the capsule that they're in and the trunk are attached to the space station. They let go and they start coming back to Earth, and they eject the trunk, and it just lands somewhere, sometime. Yeah, exactly. And SpaceX says it'll burn up completely. Don't worry about it. This is the last ground track of the Crew Dragon trunk from the Axiom 3 mission. If you were looking south from Calgary at just the right moment on February 26th, you would have seen a very messy shooting star, which a few seconds later crashed into farmland northeast of Regina. Farmers found this. Many farmers found this, right? And why did they find this? Because this is what Saskatchewan looks like in April, right? So it fell in February. It fell on snow. Farmers did not find it until April when they went out to check soil temperatures and make sure that there wasn't any giant pieces of garbage in their land, right? So Barry Sawchuk is the first farmer. He's the farmer who went to the media. And then they called me, and then I had to figure out what to do because this gets really weird really quickly. So yeah, SpaceX had said this will burn up completely, but like, look at these pieces. These are so big, right? Like you can see like my gloved hand on the solid piece of aluminum that's supposed to burn up. Really? So yeah, and these are big. Like it would absolutely kill you if it landed on you, right? Okay, so the farmer knows that he's found space junk because there's no other explanation, and because he Googled parts numbers on the pieces that he found. So, which is such a farmer thing to do. Yeah. And so he knows that he's found space junk. I know that he's found space junk because I immediately asked Jonathan McDowell, who keeps the best civilian database. And he was the one who told me Axiom 3 Crew Dragon. That must be what it is. So now what do I do, right? Like what do I do? It's like me, the farmer, and the media know. Well, who do you tell you found space junk in your yard, right? So my first thought was, oh, CSA. I've emailed back and forth. I'll email the couple of people who work there that I've emailed before, and they wrote back and said, I don't know, email SpaceX. Like, come on, SpaceX never responds to anybody. Like, that's not going to do anything. So then one of the neighbors who found space junk, he called the Transportation Safety Board, because that's who you would call if a plane crashed in your yard, right? And they never wrote back. So then I was starting to get a little desperate, so I tried calling the Saskatchewan Turn-In Poachers and Polluters hotline, which is one of the funniest conversations I've ever had. But like, you know, a rural municipality in Saskatchewan does not want to try to sue Elon Musk for littering, right? Like it wasn't going anywhere. I have since learned that it's actually, so this is the Canadian Space Agency's official stance, is that you are supposed to tell the RCMP, and whatever small town RCMP officer you have is supposed to know what to do with space junk. So I have my doubts, but this is the official line, is the RCMP is supposed to deal with it. But it turned out that actually what was the most effective was small town media, right? So Ituna, Saskatchewan is the closest town to where Barry Sawchuk lives. They have one newspaper with one journalist, and she's so awesome. And so Barry had been going around to different, CTV, CBC, like, I found space junk, and they're like, you're crazy. No, you didn't. And so she wrote it up, and that was what finally got people to believe this is real. Whoops, we got some feedback. Okay. So yay, small town journalism. Support your local journalists. Okay, so the only precedent for this, the only laws that exist are from the Apollo era, right? And the only time they were tested was when the Soviet Union had a nuclear powered satellite that crashed over northern Canada and caused a lot of really long lasting damage. There's a fantastic podcast about this by a local Indigenous journalist who grew up there. Operation Morning Light. I highly recommend it. It is super depressing, but super interesting. So the Soviet Union had to pay Canada some like piddly amount of cleanup money. And that's the only precedent here. So, okay. So the Outer Space Treaty and the Space Liability Convention say that if SpaceX had a piece of a SpaceX rocket had damaged someone's house in Canada, the US government is absolutely liable and they would have to pay the Canadian government. It says nothing about a private company and an individual, right? So, and in this case, it's even weirder because there was no damage recorded, right? So who has to deal with that? Apparently 2 guys in a U-Haul. So Barry Sawchuk, he told me when SpaceX had been in contact with him, they had him write up an invoice, for retrieval and storage of spacecraft components, and they did pay him, not very much, but they did pay him. Yeah, $5,000 per family is the going rate for space junk, if you want to know that. And so these 2 guys showed up. Barry Sawchuk had invited me to have journalists come to keep SpaceX honest. I'm like, okay, I can do that, sure. So they were not very happy when a whole flock of journalists chased them across the yard asking questions when they pulled in their U-Haul, but they did not answer a single question. It was so annoying. I realized, so after watching the journalists yelling questions at them for 20 minutes or so, I realized this is my only chance to talk to SpaceX. They will never talk to me otherwise. So I brought donuts because I thought maybe the journalists would be annoyed because I invited everybody, but it was fine. It was fine. It was a good party. But I took the donuts and I said, I went up to the SpaceX guys hey, do you want a donut? Are you hungry? Just trying to break the ice a little bit. One of the journalists behind me said it's okay, you can trust her, she's not a journalist. And I said no, I'm an astronomer and I'm pretty sure that's what I looked like. And they didn't take any donuts. So so then they packed up the pieces of debris. They drove off, and I don't know if they actually took the debris back to California to study, or if they dropped it off on the side of the road, or if they took it to the Regina landfill. I have no idea. I have no idea. SpaceX, to my knowledge, has never publicly acknowledged that this happened. NASA acknowledged that SpaceX did this, but SpaceX has never publicly acknowledged this. It is so weird. And of course, this is happening more and more frequently, right? Uncontrolled reentries like this are standard. They're supposed to have a less than 1 in 10,000 casualty risk, which is kind of high, actually, right? Especially for how frequently this is now happening, right? Right after the debris was picked up in Saskatchewan, there was another piece that was found from a different Crew Dragon trunk that fell on North Carolina. Right, and there's so many pieces that are getting dropped. There was even an old Soviet Venus probe that re-entered last year, landed in the ocean, luckily. Right, and then there are all sorts of explosions around the SpaceX launch site. It's just So okay, so 1 in 10,000 casualty risk, which is what Starlink first said they were going to have. So all of the systems for evaluating satellite risks are set up for single satellites, right? So SpaceX says, okay, we have a 1 in 10,000 casualty risk. We're going to have 12,000 satellites. And the FCC said, so they basically said, we're going to kill 1 person every time we deorbit all of these, right? And the FCC said, okay, great, because they're not set up to regulate this. They're set up to regulate radio broadcasts, right? It's bad. And Starlink satellites are not small, right? The ones that they're launching now they're trucks, right? They're Ford F-150s. So that's where we are now. Right? Low Earth orbit is getting crowded. The total number the total number of payloads, you can see there's this like hockey stick in the orange line here. That's when Starlink started launching, right? So that's the active satellites. The number of fragments, you can see there's these jumps. That's for when there's a collision and a whole bunch of debris gets added. And those are just the trackable fragments, which is like 10 centimeters or so. There's lots and lots of smaller pieces that are lethal if they hit a spacecraft, but are not trackable. So this is where it gets kind of scary. So this is a paper that some of my collaborators and I have put on the archive now. Got a lot of press. So looking at how often do close encounters happen within a kilometer, right? And so you can see there's these dips, right? So this is where close encounters are happening every 15 minutes. So within a kilometer, that sounds like a big miss, right? But everything in orbit is going at 7 kilometers per second. That's really close, right? That's really close. And Starlink themselves reports that they, in their whole mega constellation, they do 1 collision avoidance maneuver every 2 minutes on average, right? Like this is, so every 2 minutes there's a chance for something to go wrong. They are maneuvering at very low collision probabilities, which is good, and that's the only reason we haven't had a collision yet. But it's just crazy how dense it is, right?
Sorry, what is there elevation on that graph?
Sorry, the altitude here. So sorry.
How high do they fly?
Oh, okay. So Starlink is between like a little under 500 kilometers and 550 kilometers is kind of that. Yeah, the space station is like here or so, right? So yeah, there's a lot of debris. Yeah. So this is a plot from a paper by Kessler, Donald Kessler. If you've heard of Kessler syndrome, it's this idea. So he wrote a paper back in the 1970s that what if there's a collision between 2 satellites that makes a bunch of debris that takes out more satellites, makes more debris, you can get this runaway collisional cascade. That's the Kessler syndrome. That's the worst case scenario, right? And so this is a very unintuitive plot, but basically anytime this gray line, so this is real things in orbit, anytime that gray line is above the black line, that's where you have a high enough density that if there's a collision, you will have a runaway collisional cascade, right? So you can see there's this whole area out here at higher altitudes, and there's one little bump right here. So I'm going to squish that plot down and compare it with the plot that I just made. So this little bump right here, that's Starlink. Where Starlink is. So I keep hearing this in the media, like, oh, you can't get Kessler syndrome at Starlink altitudes. But this paper by Kessler, it says, yes, you can, right? And there, yeah, so as a result of that, I think there has been news just in the last couple of days about Starlink changing what orbits they're using. So they're going to lower and lower altitude orbits, which does reduce the risk of Kessler syndrome, because at lower altitude orbits, you get a collision and the pieces much more quickly will fall into the atmosphere. So, but it also means that you need more fuel to keep your satellites at that altitude. It means that satellites won't last as long. It means that they will be burning up in the atmosphere or hitting the ground more frequently, and they will be much brighter. So this is actually not great. So this is a metric that my collaborators and I came up with called the crash clock, which is a very silly acronym. I just like the name crash, so we kept that. But this is looking at so in the red zone here, there's a probability if you're in that part, like you have enough stuff in orbit that you're in that part of the crash clock, that means that you have a probability greater than 50% of a collision every 24 hours if everything stops maneuvering, right? So we're at like 3 days. So if everything stops maneuvering, we will have a collision in 3 days. Right? And so that's how reliant we are on perfect operations in orbit. That's scary. Okay, so that's the orbital dynamics, which is kind of my favorite part, but there's also a bunch of other problems that I just will very quickly go through, right? To get all of these satellites into orbit, you need a lot of rocket launches. And a rocket launch by itself, like there's a lot of pollution, but it's just one rocket launch, right? When you start getting hundreds or thousands of rocket launches a year, it starts to become really significant, and it's depositing exhaust at very high altitudes, which have all sorts of weird chemical reactions that happen at these very rarefied layers of the atmosphere. Let's skip that. We already know that rocket launches create these ionospheric holes that's kind of like human-made auroras that happen after a rocket launch. We know that the noctilucent clouds, these high altitude clouds that you see in the summer, they're much more common than they used to be, and this is because of rocket launches. The chemistry in the upper atmosphere is already changing. But what's really scary is the reentries, right? So Starlink, if you just run through the numbers, so on the conservative side, they want to have 30,000 satellites, each of them about a ton. If they're replacing them every 5 years, which is their operational lifetime, that's 16 tons of satellite per day that will be burned up in the atmosphere, right? And so you can say, well, but there's 50 tons of meteorites that burn up in the atmosphere every day, but meteoroids are mostly rocks, right? They're mostly silicates. They don't have metal in them, very little metal. So this is like 25 times the natural infall rate of aluminum, for example. And we're already exceeding that. So during the first part of 2025, Starlink re-entered 500 Starlink satellites, right? So they already doubled the natural infall rate of aluminum. And this is measurable already. Stratospheric jets have measured particles and shown that 10% of aerosols are already from reentries. And this was like 2 years ago, right? Before that 500 reentries happened. So this is already measurable. And you can see, right? So there's this pink line, right? That hockey stick in the number of satellites. The hockey stick in reentries is just starting. So it's going to change more. Okay, so, and then whatever doesn't burn up, right? That's the plan for everything in orbit, is to just burn it up in the atmosphere. Whatever doesn't burn up will hit the ground. So now I have to tell you another story. So for the 1-year anniversary of the Ituna debris fall, Jonathan McDowell very graciously came on Regina's CBC lunchtime call-in show with me. And I'm pretty sure nobody from Harvard has ever been on the Regina CBC lunchtime call-in show, right? So I wrote him an email like, thank you so much for doing that. That was so nice of you. Hopefully we never have to do that again. And then 3 days later, he emailed me this document from SpaceX and he said, you should read this. And I was like, okay, well, if Jonathan McDowell tells me to read something, I'm going to read it. So it's this long document that talks about how good they are at burning up Starlink satellites. We're so good at it. They burn up completely, except for this one time. And I read very carefully. Until August 2024, a piece of a Starlink satellite was found on a farm in Saskatchewan. I'm like, wait, what? So the pieces that I saw were from a Crew Dragon trunk, not a Starlink satellite, and it was in February that they fell. What is this, like a ChatGPT error? Like, what is happening? So I got confirmation indirectly that this is real. They did actually find a piece of a Starlink satellite. Nobody I talked to in the Canadian government knew about this, even though it's supposed to be like a state-to-state discussion when debris from another country falls on another country, right? So I went on another lunchtime call-in show and I just on a very long shot asked, hey, does anybody know about this Starlink piece that was found? And I made a burner email account because I thought, like, I'm going to get so many weird emails. I got exactly one email from a guy who said, oh, that's my friend. I'll send you his contact info. So this is the piece of a Starlink satellite that fell. So it's like, you know, this big, definitely lethal if it hits you. It fell near Swift Current. It was discovered on growing lentils as he was going to combine. And SpaceX paid him $5,000 and he FedExed it to them, which is pretty weird. Yeah, and definitely illegal, but okay, whatever. Yeah, the thing that's really scary about this So why Saskatchewan? First of all, like, why is this is me? Are they aiming for me? Like, I hope not. But yeah, it's because it's easy. It's easy to find them, right? Like, yeah, it's easy to find them. Most of the land, like 50% of the land, is big monoculture farms that get completely reduced to stubble every year, right? So it is easy to find stuff. We are the debris detector. That's what it is. We're also, just because of the orbits that have been chosen, we are under the densest band of satellites. And so with these uncontrolled reentries, if you just took a snapshot, right, of where the satellites are, the densest part is right over, well, we're under that too. I hate to break that, but yeah. So then if you just sort of do a very simple model of like, okay, all of the Starlink satellites that are up there now are going to re-enter somewhere based on their orbits. You can get a plot like this. And here's Saskatchewan. It's just that it's easy to find here, right? If that Starlink piece had fallen in BC, you would never find it. If it had fallen in Quebec, you'd never find it, right? It's just because it fell in Saskatchewan. So how many pieces have already fallen? Like, that is scary to me. That is terrifying, right? Because they've re-entered almost 1,500 Starlink satellites already. So yeah.
So what proportion of red dots are there to blue dots?
Yeah, exactly. And the green dots that are hitting Canada at all, right? But like, like if you found that in a city, you wouldn't think it was space junk. You'd think it fell off a car, right? Like, so how much space junk is on the ground that hasn't, like, that's just not being found? So that is really scary to think about, right? But don't worry, SpaceX says it burns up completely. So okay, so then back in September, part 3, there was a Starlink reentry that was visible. It was seen in Victoria, Vancouver, Calgary, and Saskatoon, and you can see in the videos. So it's like a routine now. Like, I get a grainy cell phone video from a reporter. I email Jonathan McDowell, and he tells me, "Yep, that's a Starlink." And so you can see in the pictures, like in Victoria, it's like one shooting star, right? And then by the time it gets to Saskatoon, it's all these pieces, right? So here is a video from the Global Meteor Network, which is supposed to be looking for fireballs, right? So this is over Saskatchewan. I counted 15 pieces when I was looking at this. So how many of those pieces made it to the ground, right? And so this is the ground track. So I don't know. I got a lot of media attention. It was right when harvest was wrapping up. So but a lot of the people I talked to who are experts on this said it probably kept going into the boreal forest. So we'll probably never know for this one. But don't worry, there'll be more reentries. So yeah, there's a whole bunch of other companies that are lined up to do the exact same thing here, right? There are 1 million planned satellites, right? Like, we cannot have 1 million satellites in orbit. Like, there's just no way to do that safely. And there's this stupid giant thing, AST Space Mobile. So they've started launching ones that are 4 times as big as this. And this is the worst. This is the worst. And this is your first action, your first homework item. So Reflect Orbital has a plan to launch space mirrors and to reflect so 4 times the brightness of the full moon, reflecting onto solar farms for money at night. But like, it's not enough to actually power solar panels. It's not nearly enough if you actually do the calculation. So they need hundreds of them to shine on the same solar farm, but they're in low Earth orbit, so they're moving at the speed of a Starlink satellite, right? So they can only shine for 4 minutes before they need to sweep along the ground to the next one. And if you actually look at it, so someone did a physicist and an optometrist did this calculation for the Russian space mirror, which was a total failure in the 90s. If you look at it with binoculars, you could go blind. So they're gonna launch. They're gonna launch. They have submitted to the FCC. They got questions back from the FCC that are super easy for them to answer. They will probably open up the comment period later this month. So Dark Sky has an open letter to Reflect Orbital and their investors, which is very smart. There's a QR code here, and the web address is also written out there. So this is where you can put your names in, and you can get information from them about when the FCC comment period opens, because that is going to be our only chance to complain about this for anybody in the world before it launches. So yeah, I hate this so much. But yeah, so yeah, we can't have tens of thousands of satellites in orbit without severe consequences. Right, these environmental consequences from the reentries, the ground casualty risks, and if we go into Kessler syndrome, nobody will get to use orbit for decades to centuries until that clears out. We need to think about how to use Earth's orbit now so that future generations can use it. Right now, it's just whoever gets there first gets to use it. How do we prioritize that? How do we prioritize what's most beneficial? Because it's not set up for that at all. The Outer Space Treaty and the Space Liability Convention are not well suited to what's happening now. And they need to be updated and enforced. And that is totally not going to happen. There are discussions happening at the UN level, but like it's so slow. And meanwhile, SpaceX is launching 60 satellites every couple of days now. So here's your homework list. And this is not meant to be like a guilt trip or anything. This is just like when I see a really big depressing talk, I want to do something, right? So here's a list of things that you can do. Pick one or think about, there's some easy ones on here, right? So SpaceX will only respond to legislation, which is very slow and is totally not going to happen in the US now, and to consumer pressure, right? So if you have alternatives, don't use Starlink. If you don't have alternatives, because like, I don't know, my neighbors use Starlink in Saskatchewan, right? Because there's not great alternatives in rural Canada. So if you don't have alternatives, if you use Starlink, tell them as a customer that you're concerned about their safety practices, that you want them to figure out how to deliver their services with fewer satellites, right? They'll listen to you more as a consumer than they will to me as a complaining astronomer. Tell people what's happening, right? Most people have no idea how dangerous the situation in orbit is. Talk to all levels of government that you have access to about other ways of getting internet to people, right? Because rural and remote internet in Canada is terrible. And so, of course, people are excited to have Starlink, right? It's a lifeline to, especially like a lot of First Nations have terrible internet connectivity, right? So, and that's because the infrastructure is so far behind. And then all of you, many of you are amateur astronomers and you volunteer your time to show people the sky. Thank you so much. Keep doing it. It's so important to remind people of what's up there, what we're losing, and what's worth fighting for. And get out and enjoy it yourselves, right? And then there's a bunch of groups that are trying really hard to fight this in some organized way. I am one of the co-chairs of the American Astronomical Society, the Committee on the Protection. Oh gosh, I'm never even going to remember the name, but it's on light pollution and satellite pollution, and including radio spectrum pollution. The IAU has a group specifically dedicated to satellite pollution. Dark Sky is doing great work. And I'm trying, I just don't have time, but I'm trying to start some kind of committee between CASGA and RASC and something that's more focused on satellite pollution. I know there's great work that's been done on ground-based light pollution within RASC, and we got to just look up with that a little bit, right? So yeah, there's a lot of options here, right? And we really are, like, those of us who look up at the night sky, we are the canaries in the coal mine for this environmental disaster that's happening in orbit. And so, yeah, just be loud, because a lot of people don't even notice that this is happening. So there's a bunch of contact information for me, and I'd love to answer lots of questions now. So thank you.
Thank you very much, Samantha. Does anyone have questions?
Dave Payne has his hand raised. Followed
Thanks
by
for-
Jeff Tifnick.
I'm wondering if it would be useful for Samantha first to unshare her presentation.
Oh yeah, I can do that. Yeah.
Then I can see
And
who
you
has
can
a
see better.
question.
Yeah.
There we go. Dave Payne.
Yeah, thanks, Samantha, for a really nice talk. is a huge problem, and that list of additional companies that want to have their own satellites, making quite a redundant system. It's just like the Wild West.
Yeah.
Yeah.
7 kilometers a second. Yeah.
But I think you were letting legislators a little bit off the hook here by just calling them slow.
Yeah.
Because I think the regulators, unless there's laws, they can't stop this from happening. They're just powerless. So we really need to have a framework of laws, and I know there's international problems there, but that's really where the heat should go.
Yeah, no, I totally agree with you. It's a really tricky one though, because like, so if Canada says, okay, we're gonna put a fine on Starlink because they are making our publicly funded scientists less effective, right? Then Starlink can just say, okay, well, we won't provide service to Canada then, right? And then we get all of the downsides and none of the benefits, right? So it has to be international. It has to be uniform across the whole world. Otherwise, you get flags of convenience, and you get, it's a tricky problem. So yeah, I totally agree with you. There needs to be a lot more regulation in place, but it's like it's already up there, right? It's so frustrating. There needed to be more regulation 20 years ago.
Yeah, but I mean, Bell phone company ran phone lines everywhere.
Yeah, right.
And then other companies wanted to run their own lines, and what we did was we forced Bell to share those phone lines. So if you say, there's no denying people all over the world who don't have a wired connection to internet, but at the same time we can provide that but minimize the impact by some coordinated effort.
Yeah, absolutely. Yeah, sharing infrastructure, right? Like that is great, but how do you tell Elon Musk to share anything, right? It's so hard. But yeah, I totally agree with you. You have really good points.
Yeah, I don't want to demonize Elon Musk. He's within his, and some people would say he was a hero for providing them internet, right?
Right.
So,
Yep.
But
syndrome.
thanks. Wonderful talk. Thank you.
Thank you.
Jeff, you have a question.
Yeah, thank you. Samantha, thank you. That was really an interesting talk. Similar to Dave, I mean, it does strike me that this is really the Wild West above our heads. One of the things you said, though, really struck me, and if I recall correctly, you said that Starlink is talking about an avoidance maneuver on average every 2 minutes.
Yep, that's what they're doing.
It sounds amazing. I didn't realize they had that kind of maneuverability, but I guess it's to allow them to change orbit. It sounds like there's a disaster pending there also. If any of those satellites, or if a lot of them run out of fuel prior to deorbiting, there's it's going to be a major Kessler syndrome. Do you have any sense of what kind of fuel they actually carry to maneuver?
Oh, that's a good question. I am not an engineer at all, so I don't know what kind of, it's some kind of I mean it's just like little bursts of some kind of something that evaporates. Sorry, I'm really outside my area of expertise, but it's
just that again, I assume it was to enable them to maneuver in orbit to get the best reflection. And I guess they do adjust from time to time, but it sounds like if they've gone up with minimal fuel, or I mean, are all these thousands of satellites actually being tracked with that degree of accuracy?
Yeah, there's a couple
it implies everything's being tracked.
Yeah, there's a couple of private companies that track. The U.S. government is the biggest tracker of satellites that makes them public. What's really bad is when lots and lots of satellites all maneuver at the same time, right? So that happened during that really big solar storm back in May of 2024, right when all of the debris was found in Ituna. And so the positional uncertainties on a lot of those satellites went up to a kilometer. right? It's really bad, right? Because they're all maneuvering to avoid, because they're all falling much faster than they normally do as the Earth's atmosphere puffs up from the huge amount of energy coming in from the solar storm, right? And we're at solar maximum, right? Like this is bad. This is gonna happen again. We've had a couple of major storms like the one in November. Same thing. So the positional uncertainty is really dangerous. That is the biggest uncertainty when they're all changing at the same time.
Mhm.
I hope that sort of answers your question.
Okay, yeah, it does. Thank you.
Is the maneuvering done automatically by computers?
They say it is. I don't know if it is or not, but yeah, it has to be.
Too much to be done.
Yeah, it has to be on some level. Yeah,
Good
yeah,
question, Lou Central.
yeah.
If they're doing the maneuvering, they know role shouldn't they?
Yeah,
Theory?
yeah, but they're relying on private companies and the U.S. government to give them that information, which is its own kind of scary. Yeah, yeah.
Would a large solar mass ejection just throw everything out of kilter?
Yeah, definitely. Yeah. And that's what
where the 3 days comes from.
Yeah, exactly. So the storm in May of 2024 was about 3 days, right? So it's like we want the crash clock to be a lot longer than that. We want them to have time to recover after a big solar storm. So yeah, it's 3 days is too short.
Yeah. Just a reminder in the room that you have a microphone. So one option for questions is to use the microphone. Another one is for the presenter or someone in the room to repeat the question, because sometimes
sorry, yeah.
that's okay. We hear your answer. We hear an answer,
Okay.
but on Zoom we don't always hear the question.
Okay, I will repeat. Thank you.
Thank you. Chris Gainor, you have a question.
Just a couple of comments. I was interested to hear about Operation Morning Light.
Nice.
Like there was 2 books. This is a big deal.
Nice.
This wasn't just a Russian satellite crashing on Earth. It was a nuclear reactor.
Yeah.
And it spread nuclear waste. So that was a big deal.
Yeah. There was one Canadian government person who talked to the farmer who found the piece first, and that was his first question was, "Are you feeling nauseous? Is your hair falling out?" Because he was thinking of that example, right? So luckily, Starlink satellites and Crew Dragon trunks are not nuclear powered, so we don't have that problem at least.
That's right. And yeah, the orbital debris is becoming a huge problem. A few years ago, there was a really great IMAX film that showed downtown on orbital debris. I don't know if you've seen that, but
no, I haven't.
And actually, when they had the premiere, Kessler himself showed up. So I got my butt down there to see this. I wanted to meet Kessler because he actually, before Kessler, there was a fellow named Bert Koerpele who started working on this.
Yeah.
And he was one of the Avro Aero people who went to NASA in the 60s that I wrote about. So I interviewed Bert Koerpele and
cool.
Unfortunately he's long gone now, but
yeah.
Anyway, this is I loved your talk. Is really great, and and certainly the legal regime is really a problem because it was kind of cooked up in the time when only governments were launching spacecraft, and that's not over with. But then in the United States, anything that touches the private sector, they get into the act and not in a good way necessarily. So, and David Lee has just found that movie, I think. So, I would recommend it.
I'm not sure if it's just indicating an advertisement for it. I don't know if it's available anywhere. I'm not sure. 2012.
Yeah.
2012. Okay. Susan, you have a question.
I do. I have two questions. Could the space debris cause forest fires?
Oh, that's a really good question. I've wondered about that. So, most space debris is actually pretty cold when it hits the ground, I think, which is like it's just it's burning up so quickly that I don't think it has time for the heat to really get through. Again, like I'm not an engineer. There was recently a piece of space debris that fell in Australia that was discovered on fire. And the theories that I heard from Jonathan McDowell was that there must have been some fuel left in it or something that would cause it to burn, because most of the time it's not. But yeah, I have also wondered that. And you know, yeah. Is this a good conspiracy theory to start? No, it's not. Like no conspiracy theories, no. But it's an interesting question.
My other question is, has any piece of space junk bunked somebody on the head, fallen in their house or whatever?
Yeah,
whatever?
there was a woman in like the 1980s who got hit by a piece of space junk and she was fine, which is pretty wild. Yeah, she was fine. Yeah. Like I forget her name, but yeah, there's like a Wikipedia article about her. She got hit by a little piece of space debris, right? So like I don't know that piece, the Starlink piece that we saw, right? Like I don't know, when I first saw the picture of it, I was joking with a collaborator that like it'll either like bounce harmlessly off of you or decapitate you, depending on how it's spinning when it falls, right? So but other than that, there's not anything. There was an airliner that there was a theory that it got hit by space debris. That was like a couple months ago, and it crashed into a weather balloon. And that like it broke the windshield of the airplane. But so I mean we're at the point now where it's gonna happen. There's a few % chance per year of someone getting killed by space debris. So it's gonna happen at some point, and that's horrible. That's horrible.
There was Skylab too. There's some
Oh
big
yeah,
chunks.
Skylab, yeah. That and so that was one reason that I tried calling the Saskatchewan Turn-In Poachers and Polluters Hotline, was because there was some small town in Australia that sent a littering bill to NASA, right? And I thought, like, can we do that as a publicity stunt? But nobody wanted to do it, so yeah.
I've got a question.
Thank you.
And there's one before. Dan Hogan has written, can the tracks from all these satellites be algorithmically removed in astrophotography software? If so, how effective would such a technique or algorithm be?
Yeah, there's a lot of software for removing satellite streaks. You can also just like combine images. I think if you median combine, right, you'll get rid of those streaks very easily. But it's you're losing data, right? You're losing data. If you're using a publicly funded telescope, you are wasting taxpayer money because of the actions of a for-profit private company, right? And I heard one astronomer describe it as it's like chemotherapy for your images, right? Like it's you can get rid of it and you can cut it out, but it's not perfect, right? So yeah.
Marjie, I've got a question.
Okay, go ahead.
The Legacy Survey of Space and Time.
Yeah.
Vera Rubin Observatory is going to be very badly affected by this.
Yes.
And I just was looking at an article about this, that they know how to get rid of the central track, but these big wings that these satellites have actually go like an arc minute across.
Yeah.
And they're very faint, and they don't have an algorithm really to do that. But what's going to happen to the LSST?
Yeah, this is just asking about LSST, the Vera Rubin Observatory. What's going to happen with all of the satellite streaks that's going to get? And so the American Astronomical Society annual meeting is happening this week, and there will be talks about it. So watch the news, because I don't actually know. Like I've talked with people who are part of the main team, and they're very tight-lipped about everything. So so I don't know how bad it actually is. I've talked to people who say it's really bad, and I've talked to people who say like, ah, it's fine, don't worry about it. So I think it maybe depends on what kind of science you're trying to do. But it will get worse. So yeah, especially as Starlink brings their satellites down and they get brighter. So but yeah, definitely like watch the news this week. There will be news articles about it this week.
Lori, you have a question.
Yes, hi Sam. Thank you very much. I was wondering, you mentioned something right almost at the end about the radio astronomy.
Yeah.
Can you talk a little bit more about that rather than the visual?
Yeah. So I'm very much an optical astronomer. So and I ran out of time to put in radio stuff. So thank you for asking. But yeah, so radio astronomy, right? So especially a lot of Starlink satellites and other AST Space Mobile, they're direct to cell satellites, right? So like your phone picks up satellites now, right? And that is really bad for radio telescopes because right there, I don't know if any of you have ever visited the Dominion Radio Astrophysical Observatory in Penticton. Like there's no microwaves there. You have to put your computer inside a Faraday cage, right? Like it is really tight security on electromagnetic emissions, right? There's no cell towers nearby. And now the cell towers are flying directly overhead, beaming right into their super sensitive instruments, right? So it is really bad. Like they could actually damage instruments if they get it just right. So yeah, it's a really big problem. There are parts. So I talk with a lot of radio astronomers. And I don't do any radio astronomy, but they say there are parts of the spectrum they cannot use anymore. And it's growing. Like there was one radio astronomer I was talking to. He said that there was he came back from vacation and there's suddenly a new part that they can't use. It's like, well, something else turned on, and yeah, it's changing quickly. It's internationally regulated, right? There's the ITU, but companies are going around that, and yeah, it's bad. It's really bad. So sorry, that's super depressing. I don't have anything good to say there.
Any other questions? Samantha, thank you very much. I'm sure I know I've wanted to hear a lot about that topic for quite a while. So much appreciated.
Yeah, thank you for having me, and thank you for showing people the sky. Keep doing it.
And you are now welcome to stay for the rest of our meeting.
I will. Yeah, I will.
Yes.
Listen.
Great.
I will
have
coffee. Yeah.
And there are cookies.
Thank you.
There are cookies, but would you like a cup of coffee?
I will stay
Dave,
Yes, the coffee is
Dave
ready.
Payne. Dave Payne, since you are having to leave early, let's have your image.
Sure thing.
Share.
Yeah, I'll forget that. Thank you very much. It's your signature.
Yeah.
Okay, is that sharing?
Yes, we can see it.
Okay, great. This is an image I showed before the holidays there of the Eagle Nebula. And I'm just showing it now to show you a new image, but I just want to put it in sort of context. So this is the Eagle Nebula is stellar nursery. It's about 2 million years old. The oldest stars are about these ones right here, are about 2 million years old, and they're blowing plasma out from them that's inside a molecular cloud. It started inside a molecular cloud. And this plasma is blowing a bubble, essentially, in the middle of the molecular cloud. And buoyancy effects are that plasma is trying to escape from the molecular cloud. So it's trying to, but there's no real balloon in it. And at this stage, it's kind of blown a hole. You can see like this. It's kind of blown a hole in the molecular cloud. And if you can imagine this in 3D, it's trying to escape. So what I've done is my next image is of the Satyr star that was in the same way started blowing a bubble inside this molecular cloud. But this image was taken on about 1/5 the focal length of a telescope, but it's also a lot closer then. So it's a wide angle scope, but the molecular cloud is 1/5 the distance from us. So it's about the same size. But this Satyr star is about 12 or 13 million years old. And it's comparable to the stars that were in that tiny cluster in the other image. But it's matured a lot longer. So that bubble has grown and it's pushed a lot of the molecular cloud all through essentially the full frame of this image. And you can see all the interactions from friction and from buoyancy effects and from inertial effects and all sorts of electromagnetic viscosity related interactions between the two clouds creates this basically mess of a molecular stellar nursery of a molecular cloud around this central Satyr star here. So there's lots of things we can investigate and learn about how these clouds interact with the plasma given off with the stars.
Dave, what is that word? Satyr star?
Yeah, that's this star here. If it's in Cygnus, it's the Satyr is from an Arabic word meaning chest or breast. So it's the actual star in the middle of Cygnus where the wings meet the body. So it's the chest of the swan. So that's how it got its name.
And I see like filaments. Some are bright and some are dark. Are they related in any way, or is it just a coincidence? Like in the bottom at 5 o'clock, there's some very bright filaments, or at 6:30, and then there's the very prominent dark ones up
These ones
up at 10 o'clock.
So in their natural sort of state of being, in their pure state of being, I'll say, both plasma and molecular cloud are invisible. Okay. What we see in the red and orange things, it's like a coat of paint on the sides of the molecular cloud that are facing Satyr. So anything bright, this is the brightest parts are facing the star. So the starlight is hitting the molecular cloud and it's the UV light that we can't see. And then the cloud is emitting these mainly hydrogen alpha, but also other ions are emitting light off of their surface back to what we can see. So that's one way we see the molecular cloud. The other way we see the molecular cloud is through dust, and dust generally blocks light. So when we see dark patch like this is molecular cloud that's between us. We're in the shadow of this molecular cloud from the lights of the stars. So it's really hard. It's really hard to put this into 3D context, knowing that if the gases weren't transparent, it would be a lot easier to interpret. But you see a lot of these filaments, it's basically wispy components of the molecular cloud that are pulled off of the surface by the plasma flowing past it. It's really a frictional effect. So the three things that are going on is expansion of the plasma against the denser molecular cloud, buoyancy effects that's trying to the plasma is trying to get outside of the molecular cloud, and thermodynamic effects like the plasma consists of not only what was emitted from the stars, but also parts of the molecular cloud that are ionized. So that's why it's expanding in the middle of this. So it's hard to interpret, but like Samantha was saying, you're looking for patterns. When you look at a lot of these, you start to be able to interpret the gas bodies that are involved in this bit of a dance that they do. Is that helpful?
Awesome, Dave. That's really cool.
Thank you very much, Dave, as
Thank you.
always. All right. David Lee, would you like to tell us about the beginner's SIG, please?
Yeah. I just had a quick question for Dave while he's still here. So Seder is right in the middle of that image, right, Dave?
Yes, I've dimmed it because if you leave everything at normal brightness, the star would utterly dominate the whole.
So there is a crescent nebula. I'm trying to get the scale of this. The crescent nebula is somewhere near there. Is it within the frame or is it outside of the frame?
It's outside of the frame.
Okay, so now I understand the scale a little bit better. Okay.
Yeah.
All right. So beginners SIG special interest group. So for those of you who are new, now it doesn't appear there's anybody new online, but if there are new people in the audience down in Fairfield, if you're not aware of the beginners SIG, certainly fire off a note to me. It's David at victoria.rasc.ca. Then let me know and I will send you a Zoom link. So it's actually tomorrow night at 7:30, and we've got a couple of topics. I think Naz wanted to understand a little bit about black holes, and then there's still some interest in 3I Atlas, the interstellar interloper. And I think there is a book review. I think Doug wanted to do a book review on something about space hazards. So that's kind of timely. So I don't know what kind of space hazards, but it's a book about it, about solar flares, space hazards, and asteroids, I believe. So yeah, everybody's welcome. Just fire off a note to me if you're not already on the list. Great, thank you.
Thank you, David. Chris Gainor, would you like to give us some space news?
Okay. Just let me get the slide going. Is that it? Nope, that's not it. Just a second. Okay. And So actually, most most of what I have to say is kind of positive today. Um, just a minute. Okay. So just after we last met, the nomination of Jared Isaacman, who had been nominated a year ago by President Trump, and then it was withdrawn and then put back in. Anyway, he was finally ratified as the administrator of NASA with bipartisan support in the Senate. Not every Democrat voted for him, but a lot did. You know, along with the Republicans, and we were waiting to see what was going to come of all this, and because NASA had kind of sustained a lot of cutbacks, a lot of people were laid off, and there was concerns that a lot of science would be wiped out. Anyway, just a few hours after he was actually sworn in, President Trump issued a new space policy, which didn't really change things that much and didn't deal with that question I just mentioned. But anyway, it was kind of showing that space was big on the radar screen, and there were some administrative changes and things like that. And so when I did up this slide this morning, I thought this was about all I could say about it, is that we were still waiting to hear, you know, which direction NASA was going to go. And in the middle of the afternoon, I got some very encouraging news. And what it is that in the U.S. Congress, you know, you have the two bodies, the Senate and the House of Representatives, and they usually pass their own legislation, you know, to appropriate money for spending on things, and they're usually different. And then they meet in what's called a conference and kind of hammer everything out. And then they go back to their bodies and pass this bill that's the same. And then hopefully the president signs it. So out of conference today came a spending bill that includes many things, including NASA. But what this does is that it basically keeps spending on scientific endeavors at roughly the same as what it was prior to the arrival of the Trump administration. I think it is cut by 1%, but at the budget proposal that had come from the administration, you know, in the middle of last year was like a 47% cut in science, you know, they're cutting it in half. And they were trying to enforce that before it had been passed by Congress. And a lot of people were laid off. A lot of people were told to prepare to wind down their projects. And assuming that this budget goes through, you know, we'll still have all the damage that was done in the past few months. But pretty well everything is going to go ahead, with the exception of the Mars sample return, which has turned out to be an extremely expensive project, and was in some trouble even before the Trump administration came into office. And then later in the day, you know, around supper time, I got word that that Isaacman had announced that funds were going to be spent on moving forward what's called the Habitable Worlds Observatory, which I think is a future generation of a space telescope that's been gone through a decadal survey from the scientists as a big priority. And so that's I'm not sure when that's going up. I'm not even sure if I'm going to be alive, even if I live to old age. But anyway, I think that's very good news and very encouraging news. You know, we still have to make sure that this thing goes through Congress and gets signed, but the word is that that is going to happen. So anyway, that's a very good thing to say. You know, Isaacman is actually a billionaire who's kind of interested in space, and he's actually purchased two of those Dragon missions and has flown on them. So anyway, that's but even before he was nominated for NASA, he was actually talking about a private mission to do another repair on Hubble, because Hubble has not been repaired since, you know, like in 15 years or something like that, since the shuttle stopped flying. So that's that item. And the other thing I want to talk about briefly is, you know, Artemis 2 is sneaking up on us, and 32 days till the earliest possible launch. They're talking about launching it in a window that could go throughout the spring, but would open on February 6th. And there's 4 astronauts going to fly on that, including a Canadian astronaut. So this is going to be very exciting. It's the first flight of this nature in more than 50 years. I think 53 years now. And so our Canadian fellow, I'm just suddenly blanking, which sometimes happens, but Jeremy Hansen, that's right. So, and these 4 folks are going to see with their own eyes the moon and parts of the moon that were never seen by Apollo astronauts. This is just kind of a schematic. I'm not going to go through it in a great deal of detail. It's going to pass around the moon. It's not going to go into orbit around the moon, but it's going to be quite a distance, and it's going to see parts of the moon which were not seen by Apollo because of their trajectories. And Apollo went quite close to the moon, about 70 miles. This crew is going to be further out, and they might see parts of the moon that weren't seen by Apollo because of the phase of the moon at the time. I think one thing that might be interesting, there's that gigantic impact thing that's not often seen, and what is it? Mare Orientale, I think it is, and they might see that, and sort of more of the polar regions of the moon. But it's going to be a 10-day mission, and this crew, if everything goes according to plan, will be going out farther than any other astronauts have ever been from Earth. I think right now the record is held by Apollo 13, by the way, and of course this path is quite similar to Apollo 13 because they couldn't land, they just whipped around the moon and came back. So I think if everything goes according to plan, and word is dribbling out, and it's it's still a little uncertain, but Artemis, or the SLS rocket, which is carrying the spacecraft, is supposed to come out of the vehicle assembly building in about 12 days, late next week, and go out to the pad, which is about 3.5 miles away. And then starting on February, the launch could take place as soon as February 6th. On this mission, which I think is going to be really exciting once people, really get their minds around the idea that this is actually going to happen. It may not it may not well happen on February 6th, and I'm not sure how the launch window is going to work, because I would imagine there would be some periods during each lunar orbit during the next little while where they wouldn't want to launch at all. So if they're held up a few days, they may actually wait the better part of a month. But I'm kind of guessing a little bit. So I think that's what I will say for today. But fasten your seatbelts. There's going to be a lot of fun with this mission. I'm sure a lot of us will get excited about it. Probably especially Randy. But anyway, that's what I have to say today.
Thank you, Chris. Lots of good news.
That's right.
Myles, you have some information to share with us.
Oh, do we have time? Okay.
We do have time.
All right.
Rockets.
Yeah, let me.
And a song.
And a song or two, yes. Well, just, well, okay, let's start one thing at a time here. What I looked up, because we were talking about it at one of the beginner SIGs, and I'm always like, electromagnetic and nuclear rockets, because like let's face it, burning stuff in the atmosphere is not a great idea. And so this is all interstellar capable stuff. But so here's what I got. Early fireworks and weapons, the first true rockets were accidents involving bamboo tubes filled with gunpowder. Who knows what they were trying to do, but when it went off like a rocket, they thought, ooh, that's interesting. So the Chinese, the gunpowder, saltpeter and sulfur and charcoal, that was the bunch of stuff. First century AD. By the 10th and 13th centuries, the Chinese were attaching these tubes to arrows, creating fire arrows. So that's how it all started. And of course, I'm sure somebody has way better information than me in this, but this is what I got. So spread and early development. The technology spread across Eurasia following the Mongol invasions amid the 13th century. By the 18th century, the Kingdom of the Mysores in India had developed iron-cased rockets, which increased their range, and the British copied these, leading to Congreve rockets, which they used in the Napoleonic Wars. And then we go into the 20th century and the space race and stuff, and there's all sorts of things going on. The First and Second World Wars. Pioneers in the 20th century, Konstantin Tsiolkovsky developed the rocket equation, and Robert Goddard launched the first liquid-fueled rockets in 1926. Hermann Oberth published influential spaceflight theory and established theoretical and practical foundations for space travel. And then really important stuff like Werner von Braun and those people inventing stages and stuff like that. But still, this is, basically the same kind of chemical-fired rockets. And then the space race, the competition between the US and the Soviet Union, they were really outclassed when Sputnik 1 went up in 1957. Really shameful, right? So they managed to put somebody on the moon by 1961. And we know all about all that stuff. We could go into any of these things forever. But the latest experimental and theoretical methods of rocket propulsion, because we want to go to the stars, right? Yes, we know time dilation means it'd be 20,000 years when you come back. Even all that stuff is a problem, but so what? We would go, wouldn't we? So the advanced things that are already happening, there's electric nuclear plasma technologies, and as chemical rockets approach their theoretical limits, they're working on these other things. Experimental and near-term methods, these are in various stages. Electric propulsion. a mature and widely used technology for satellites. I didn't want to interrupt, but that's how they move satellites around in little blips. They have electronic propulsion EP, and it's been used in station keeping and all for a while now. So that's actually up there and working. So it takes less of everything, but you just need little tiny blips and it works. Then ion and Hall thrusters. These systems use electric fields to create ions, typically xenon gas, and run to extremely high velocities, providing very high specific impulse, which they mean by saying fuel efficiency, and low thrust. So new materials like carbon nanotubes to increase thruster life and efficiency and miniaturization. This is also used on cube satellites, but that lots of growth potential. Then there's starting to get a little bit crazier. Variable specific impulse magnetophase rockets, VASIMR. This is a type of plasma rocket that uses electromagnetic fields to heat and accelerate plasma, offers the ability to vary its specific impulses to balance thrust and efficiency for mission phases, potentially reducing a trip to Mars to only 39 days. So this kind of rocket can continually fire without burning itself out. So you can just continually adding speed and then turn the rocket around and reverse it, what did I just see a movie where they did that? Somebody was talking about that recently. Then there's, so that's already possible and they're working on it. Nuclear thermal propulsion. This technology uses a nuclear reactor to superheat propellant, usually hydrogen, which is then expelled through the nozzle to generate thrust. And the prototypes were successfully used in the 60s, the NERVA program, but current research is based on modern safe reactors for missions like the demonstration rocket for agile cislunar operations. We can get into any of this endlessly for hours. Rotating detonation engines, an advanced form of chemical propulsion that uses continuous high-speed detonation waves to achieve higher efficiency, and Japan has successfully tested this in a small way. Solar sails. These use the momentum of photons from the sun, and for continuous but tiny thrusting require no propellant. Missions like JAXA's Icaros and the Planetary Society's Light Sail, oh no, my phone, have successfully demonstrated this technology in space. How do I turn that off? Off. I hung up on whoever that was. Sorry. Solar sails, so solar wind, you know, they've done all of that already too. They've had, and of course, a solar wind in space could be any size you want. And again, it just continues until you turn it around, and if you were aiming at a star, and then go the other way. Nuclear fusion propulsion. The holy grail of space exploration is the theoretical fusion systems that could offer immense thrust and near limitless energy, potentially enabling interstellar travel. Mastering controlled fusion in a compact portable reactor remains a major scientific and ongoing challenge. So every country in the world is spending, like there's 50 countries where they're spending millions of dollars on, and fusion, they've got up to a couple minutes, I believe, but it still costs about the same to set it up. So they're talking about having that in a rocket, which would be, so here's a real good one, matter-antimatter drive. This concept involves annihilating matter and antimatter to produce energy, offering the highest possible energy density, but it could hurl things at near light speed, but currently nowhere near possible doing this yet. But that's just so that's another theory. And then there's quantum vacuum thrusters. So these controversial theoretical drives propose generating thrust by exploiting quantum fluctuations in empty space, seemingly bypassing Newton's third law of motion, requiring no propellant. So the few lab setups have been reporting tiny thrusts, but they may be just largely attributed to measurement artifacts. And then there's beam sailing, sending out a beam and then pushing yourself, an extension of solar sails where high energy beams from a powerful external source like a space station exert a force and push the thing off. they did this with the Starshot project. So it has been done for interstellar flybys. So or could be done and sending things off. And then there's even more theoretically possible things like portative laser initiated fusion reactors and supercharged magnetic confinement of stellar core hot plasma and magnetic drives. So there's all sorts of stuff, you know, to get away from using the standard chemical rockets. And you can look up any of those things and find endless amount of what's going on with those. And I could say, do you have any questions? But I'm not the right person. I'm sure there's people here that have much better knowledge on all of that stuff than I do. I just find it very interesting. And every time something new comes up, I follow it and see what they say. A lot of the time, it's like, do you remember when we were supposed to have painted solar cloth and all that? It was going to be in 2 years. It was going to be on everything. Your hat, like what happened? It was a Toronto company that was working with the University of Toronto, and I haven't heard from it. And then things like they're saying as they find more and more stars just in our galaxy, they're saying there's 10 million Earths. The last number I heard was up to, there's so many planets and so many stars that there are 10 million exact like Earths. So far, that just keeps on growing. So you continue all this stuff and you want to go off into space. So I've got this song, this was written 13 years ago, and gets a little, well, I don't know, like, did this happen in 1,000 years or is it going to happen in 1,000 years? But anyway, this was written in 2012, and I'll just play it. And it does have a happy ending, so don't worry about it. So here it goes. Oh, by the way, what I'm playing, can't see it. It's a National Steel guitar, 1934 tricone, National Steel guitar. And you know, you usually hear this stuff like, right? So the tuning that I thought I invented turns out to be Hawaiian slack key ancient tuning. It sounds like that. So I tune strings down instead of up, and the guitar has to be in tune, or you just can't, because you're not touching the strings. So this is called 1,000 Captains. Starships into the galaxy core. Amid the crush of humanity's 20 billion or more. Global warming and the energy crisis and the water wars. All the salinated aquifers and swamp shores. There were 1,000 captains, and they were sailing on the solar winds. They didn't stop until they found a new home. That's the way it begins. As the cataclysmic phase, total collapse. 2030, all the markets slid into one continual crash. United Nations breakdown happened, allow the countries to fail. The ascendance of the League of Corporations was soon to prevail. There were 1,000 captains, and they were sailing on the solar waves. They didn't stop until they found a new home. That's the way it begins. There were 1,000 captains, and they were found a new home. That's the way it begins.
Thank you, Myles.
Okay.
We are a multi-talented group. Is there anything that anyone else would like to share?
Maybe I could just say something. Phil Stuke here. I have a presentation which I'd like to do next week or the week after, whenever it could be fitted into the schedule. Just looking ahead at the next 12 months and the things that are coming up in the solar system. And there's quite a lot happening. Moon landings and asteroid flybys and all sorts of things. So I'd like to do that if we can find a time for it.
So this
Phil, is that you?
Yes.
Yeah, I'm hosting next week.
Oh,
So
okay.
if you don't mind, maybe just dropping me like a topic or a title, that would be great.
Yes, right. I will do that.
Great, thanks.
Okay.
All right. Anything else? Did anyone receive any gifts in the last few weeks that were fascinatingly, interestingly astronomical? Dan, what did you receive? Oh, no, you didn't? Yes, you did.
Excuse my cold. I got a Dwarf 3 telescope. Yeah. Probably the one of the cheapest expenditures I've made so far on astrophotography. But I'm sorry, I don't really have anything to share, but and we haven't had good weather, but it is a remarkable little device, and I'm sure the real pros would laugh at it, but I'm getting some, I don't know, like at least shareable results.
So I didn't get a smart telescope this Christmas, but I did receive lots of information on an upgrade to the Seastar. So apparently the Seastar 30 just came out with improved optics, and I think it's in the $800 range. So I don't know how that compares to the Dwarf, Dan, but it looks like lots of things are happening.
Yeah, I'll share some pictures with you tomorrow at the SIG.
Oh, excellent! Thank you.
And maybe Dan next week as well at Astro Cafe.
I'm not on that. I'm not on your level yet, I don't think. But
That's
sure,
all right.
I really want to see them.
We love to see what everybody is doing.
Yeah, absolutely.
Hi, it's Malcolm. Can you hear me?
Malcolm, you have something to share.
Yeah, I've had the Dwarf for over a year. I just haven't sent any images in, but I have both a fairly big telescope on the balcony and the Dwarf. And the Dwarf I find fun because I can go anywhere with it and take some normal photographs and also some astrophotography. Last week I did the moon normal, and then I did an astro of the moon, and I posted it on Facebook, and everybody was quite fascinated by seeing both the images from the same little beast. And obviously I love the price.
That's great. Maybe Malcolm, you can share some photos next week as well with Dan, with us.
I will do that. Yep.
Yes, that would be lovely.
Yeah, I see Joe just posted a link to the Seastar. So that's the new one that just came out.
Did anybody else receive an interesting gift? Brian, what did you receive?
I got a very inexpensive photographs of some astronomical images. It's a puzzle of the solar system. So when I'm done, I'll put it up for auction.
All right.
And Brian, I want you to know that your moon puzzle is the next that's getting done in my at work in our lunchroom. There's always a puzzle going on.
Yeah.
Kind of scared of it.
Yeah, that is a tricky one. So, but all the best. It's good to have help with that one.
You could have a puzzle party. We could come.
Do you know what? After there actually is a puzzle competitions that are done internationally, and they're assigned. You sign up as a team, and then it's the team that completes the puzzle in the shortest period of time. But these teams can put together 1,000 puzzle in 2 hours.
My.
It's just amazing, because it takes me hundreds.
Well, over Christmas we did a round, took up the whole dining room table, round moon. It was really different.
Yeah, that's probably the one that I passed on to Randy. That one's really tricky because it's just all
whole
shades of gray, right?
The whole family chipped in doing that over the whole Christmas holiday.
Mm-hmm.
Anything else to share? All right. Oh, Moira, what do you have? Oh, we can't hear you, my dear. You have to unmute. There we go.
500 piece out of this world puzzle.
Yay!
And it's 500 pieces because it took me a month to do my 1,000 piece that I was working on. So they took pity on me and got 500 pieces.
Very nice.
I could play a gentle song called Peace in Our Time that is less cataclysmic than the other stuff that we did. If you'd like to hear a short version of that.
All right, Myles, you'll have to put your mouth very close to your microphone because we would really like to hear the
We
words.
should ask him to do it next week because it's 5 to 9 and we got to close up here. The custodians want us to be out of here at 9.
Yeah, no problem. We'll put you
Yeah,
we'll put
maybe
you on the
Myles-
agenda.
Yeah, how about a live performance at the Fairfield Community Center?
Oh yeah.
This is a far way away.
Thank you very much to all who participated tonight. It's been a wonderful and fascinating evening, and we'll see you next week.
Thank you, Samantha.
Happy New Year.
Yeah, thanks,
Happy
Sam.
New Year.
Bye, everybody.